Hello there. Welcome to this Shieldier guide for the medium security DAM vulnerable web application reconnaissance step. I hope if you're joining in from the red team perspective, I hope you enjoyed that and learned something. From the blue team perspective, we're not just going to look at how we can detect this activity, but we're going to take it a step further and demonstrate how we can actually prevent this activity from happening in the first place. What you see on screen is a bit of a preamble in regards to how and why I'm thinking about these things and what sort of perspectives we're trying to take. For instance, if an adversary controls your infrastructure or your enterprise's vulnerability scanning infrastructure, then what? They'd be able to pivot to anything within your network. They'd know all of the vulnerabilities, etc., etc. So just bear in mind where these adversaries may be. Now, the corollary to that is okay, you've got a web service accessible to the entire internet, but it's not actually running any any PHP, or it's not hosting any databases or anything like that. Is that really the highest priority if someone tries to try some SQL characters against it or tries to enumerate some directories, all that? Is that really the highest priority? Probably not. So just thinking about these things in a multi-layered approach. One of those layers we're going to be looking at today is ModSecurity. We're going to be installing it on the DAM vulnerable web app guest so that it will be able to provide the ability to prevent these attacks from happening in the first place. If it matches certain criteria, then boom, that request is denied with by default a 403 forbidden. You're going to want, whether or not you're on Windows or Linux, it doesn't really matter. As long as you're in the directory that you have run Vagrant up from, if you're using the Tartarus lab. If you're not using the Tartarus lab, I will caution you installing ModSecurity this way on any of the more recent Ubuntu instances or Ubuntu versions might not actually work. If it's 22.04, then there might be some issues. Just bear that in mind. You might need to compile it from source. But if it's 20.04, then you should be fine. The first thing we're going to want to do is now we would be in the directory that you would have run Vagrant up from. I'm going to SSH damn, no, I'm going to Vagrant SSH damn vulnerable web app. So this will tell Vagrant just to SSH into the Ubuntu guest. Now I will do an lsb underscore release tac a just to confirm what Ubuntu version I'm using. I know it's old, I know it's ancient, I know it's not really supported anymore, but for the purposes of this guide, let's not go there. The first thing you're going to want to do is make sure you have an up-to-date repositories list. So sudo apt update. This will just update the repositories. Don't need to worry, I'll skip. Well, it's done already. Awesome. Then we're going to want to install the ModSecurity package with sudo apt install libapache2 ModSecurity2. Here you could type Y and hit enter, but because it's an uppercase Y, it would be the default option. So you could just also just hit enter. It's a Linux a custom thing, as in it's customary for the uppercase letter to be the default in a selection like that. Don't need to worry about that too much. Moving on, we want to restart the Apache service just to make sure everything has worked. So cool, it has restarted. I'm then going to replace restart with status so that I can see, okay, it is running fine. Awesome. Clear the screen to make sure it is nice and clear. We want to create the default ModSecurity file quickly, which is sudo cp and then ModSecurity recommended. So that comes with that prepackaged. We're going to make that into the ModSecurity conf. Here, there is a list of sed commands. We're doing in place substitutions for these specific lines. So if, for instance, a line matches the word detection only, then that will be replaced with the word on, etc., etc. This is to make sure that it's both enabled and in a way that Elastic is able to understand for when we come to installing the Elastic or enabling the Elastic integration for ModSecurity. We don't need to worry about that too much at the moment. Just know that's how it will be replacing all of these things and making sure that it's in a manner acceptable for Elastic. Let's see. Okay, cool. It restarts fine. You could do status as well, but we're not going to do it in this instance. Now we need to create some directories. So we make the custom rules directory. This directory is where we will place all of the custom rules. We then copy those custom rules from the Vagrant ModSecurity directory. That will be pushed via the GitHub source controlled Tartarus lab for you to utilize. It has to be done first before we actually start to enable anything, because if it's done at a later stage, then ModSecurity doesn't see the rules and then Apache doesn't start and you have a bad time. So we don't need to worry about that. It's already done for us now. Now we want to download the latest rule set for the v3 branch, which is already done. Great. We can do a quick ls. So it's the core rule set and then the core rule set encryption or certificate. We can then use GPG to be able to verify that that is in fact the core rule set's signature. Good signature from that. Awesome. It is that. Great. Moving on, that's just saying what we need to see. We want to deflate this this archive. So now we have the directory, the archive, and the encryption signature. We want to move the specific files where they need to be with this command. So it's taking from our relative path core rule set. It's going to create the CRS setup conf example. So to ModSecurity CRS setup conf. Great. We're going to then want to copy all of the rules from the directory that we've just inflated. We then want to edit this file to look like this. I'm going to copy that and then paste it and then just quit out quickly so that it's still in the command history, and then do a, if you're in Vim, you can do a G and then capital a D and then capital G will delete everything globally. If the cursor is at the first line, it deletes everything from the cursor onwards. So in this instance, that's the entire file because the cursor was on the first row and column. We're going to I for insert mode, Control Shift V to paste it, escape to go back to command mode, and then Control X to right quit that. Awesome. So now I've created the files, we've created the rules. Finally, we're going to want to restart Apache just to make sure everything's working as expected. And Apache does restart, so all's good. Everything works. We can even do a little status to make sure that it's working correctly, which it is. Great. Finally, we're going to want to test to make sure that this does in fact work. So for example, we can go to this page within our Kali instance. So this being the Kali instance in the Tartarus lab, this will then validate whether or not our, which it does, the web application firewall correctly fires. Awesome. Moving on, we want to add the Elastic Security integration. To do this, there are a few steps. So you're going to want to be within, obviously, the blue team setup from the Tartarus lab. Then you're going to want to log in to the specific Elastic instance that you've created. Then we want to go into the management section under fleet. So in the burger menu, there is management and then fleet. Here we could see all of our Elastic agents. Fleet is sort of their management plane for these Elastic agents. We have the first one, which is the actual fleet server, which gets installed onto the Elastic node, or the Elastic guest, shall I say. Then the other one is the Elastic agent that gets installed onto the Ubuntu guest that then runs the damn vulnerable web application. So that's utilizing the Apache agent policy for those Apache logs. Once you're here and everything looks good, great, we can then go to our installation steps and go to agent policies. We're going to want to create an agent policy. No, go to the agent policies and then select the Linux agent policy, and we want to add an integration to that. So here, agent policies, Linux agent policy, add an integration. We want to search for ModSecurity audit. Click that. Make sure, see here, this is what it's specifying some of the defaults should be. So in the previous step, when we edited the etc ModSecurity / ModSecurity conf file, this is what we were making sure it looked like. Making sure the audit parts look like this, because there's some issues if it doesn't look like that. Namely, if you're logging list rules match transaction K, insec audit parts, this will break the parser. So don't do that. Make sure it doesn't have that. But we want to now add this. We want to make sure where we are adding it. We can leave that default. That's fine. Paths, I don't know why it's hyphen, but there it explains it as underscore. We don't need to worry about that, but just replace the hyphen with an underscore here. Great. Where we are provisioning this to would be existing hosts, and then the specific agent policy, Linux -Apache. This could all be done via an API. You don't actually have to point and click this, but just for one of example, you can point and click this, and then this will update one agent, save and deploy. Awesome. Just to give you an understanding of how these agent policies are deployed in the backend, if you're not doing them via an API, which the Tartarus Lab does everything else via an API, except for this, because it's a custom config that we're adding on top of the default setup if you wanted to follow along with the actual prevention of these attacks, because I'll be providing both the detection, updated detection rules, and prevention rules. If you don't want to follow along, that's perfectly fine. I keep doing that. Why do I keep doing that? Then, okay, installed, integrated, great, deployed, making sure we've changed that. Awesome. Save and continue. Now we should hopefully be able to see it within our seam. Here again, burger menu, discover, make sure you're setting it to the logs and not just metrics. In the data view, I want to see my logs. I want to see an event.data set ModSecurity audit log. There we go. Now this is the default one that you'll get every second, because the way that the Elastic agent is confirming the status of the web server is it's doing like a request to it, but it's doing a request to it via 127.0.0.1, which the WAF will just block by default. So it looks like SSRI. So we don't need to worry about that, but we should see logs. Again, run the search for that. Great. Here's just explaining, don't worry about that. We could then do a little fuzz foster ufull to see if the logs are being correctly ingested in a way that everything's working as we would expect. This is what we did previously with fuzz foster ufull, but this is just using the get method. And then we are trying to enumerate all of the directories underneath the parent root directory that our Apache web server is serving. You'll notice it's a lot slower now. This is a deliberate part of the ModSecurity cycle, that there is a little bit of a wait function so that the requests don't happen so quickly on your server. You would have noticed there would be thousands of requests per second. Now it's down to maybe 500 requests a second. Just something to keep in mind. You could let that run. It will never actually get the response code 200 because it's all going to be 403s or forbidden, because why? It's using the default user agent, and that's already in a list for the for ModSecurity to be able to identify, this is actually a bad user agent. To exemplify this, we can then go here, do a little refresh, and you should see a big bar with a lot of logs, which we do right here. We can then just click on that. It'll then expand that to the time frame, matched phrase fuzz foster ufull. So it's able to correctly identify the header and then just block it. Awesome. So now that we know ModSecurity is working, everything, the core rule set has been correctly applied, everything's working, we can take it one step further and do some of these tests. For instance, this is utilizing both of the obfuscation methods discussed previously. We will obfuscate via the specific method. We're changing it to head, and we are customizing our user agent, and it will run. And you can see here the different status codes, because we're not giving it a match condition, is all of the status codes except for like 404, but it's not even giving us a 403 forbidden. It's continuing on because it's not able to correctly identify our custom user agent as being nefarious. Great. If you let that run, eventually you'll see something like this, that it's able to correctly identify the damn vulnerable web application subdirectory that'll be served on. And then again, you could look in the SIEM and you won't see any logs for it because it is, from the web application firewall's perspective, considered normal traffic. Now we want to fix some of the SIEM rules that we created in the low security part of these guides. One of them, for instance, is the Sigma Web Apache Correlation Directory Enumeration Medium Security is the new rule that should fire for the specific activity that we have undertaken. It fixes the other rule that doesn't have medium security at the end. So if you look under the alerts page, we should see for the activity, awesome, 13 alerts, some path traversal, some correlation web directory enumeration attempts. So this rule is just an update on the other rule that already exists, removing one of the premature optimizations. So here it's from logs Apache default. Then we want to include some other stuff where Apache response code status, apache.response.status_code is 404. But we're not doing the method is get, because this could then apply to head method or any of the other methods. And then we're just giving it a time bucket of 5 minutes, and then alert where over count is equal to or greater than 1,000. And then that runs the rule. Awesome. Now looking at, so that fixes the issue with the low security rule. Now, if you wanted to write your own mod security rules, it follows a particular pattern, and we will put them all in the directory that we created earlier, the etc mod security custom rules directory. So here we define a rule. So we define it as sec rule, and then request method is one of the keywords that they have, equals post, and then we define it with an ID. Then here we're just doing backslashes because normally it's all in one line, but it's not the best to look at if it's all in one line. So you can just define it with a backslash, and then you'll define it with either tab or spaces. The specific phase that we're looking at, so here phase 2, just to diagram it out, phase 2 is your particular request goes into a wait period, then goes into this post read request, which is phase 1 of the chain. Phase 2 contains the request body. Then phase 3 contains the response headers. Phase 4 contains the response body, and then finally the phase to log everything. So each time there is a request, you hit the wait. So hence the delay when we were doing fuzz foster you fool earlier. You hit phase 1, which has the request headers. Phase 2, the request body. Phase 3, the response headers. Phase 4, no, I'm kidding. The response body, and then finally phase 5. So here we're looking for within phase 2. So what does that mean? The request body, we are looking for a specific entity. So this is to block the undocumented main page brute force attempts, because I was looking at it at 2 different perspectives. Firstly, I was like, oh, we could just block it like you'd block a normal brute force attempt. After 5 requests, just block it. But then I realized, well, why don't we just block all requests without a user token? Obviously, that'd be a more effective way of doing it. So we deny, we set the status to 403 or forbidden, we set it to log, we set it to audit log, we give it a message so that this will be printed within the log, we give it some tags, and then we give it another directive, sec rule. The request URI has to end with damn vulnerable web app /login.php. We're chaining this together. So you see this one's chained, and then the final sec rule is args. We're looking at the arguments within, because we're looking at phase 2 within the request body itself. We're looking for arguments. User token is nothing. If the user token is nothing, drop it. Bye. We can then test this if we wanted to using the nuclei scan that we ran previously. I don't know if I do it in the blog post, but just by way of example, this now won't work because the user token is empty, so it just gets blocked. And then that's just explaining sort of what I've explained there. Finally, we could move over to the purple team perspective. I'll see you in a little bit for that. And then finally for today, the purple team perspective. So we're utilizing nuclei as I've just demonstrated within the blue team perspective. We can use it to be able to verify that the scan will fail because we are blocking those requests with that particular pattern, as in it doesn't have the user token. We can view it in the seam as well if you wanted to. You'd do an event data set and not user agent.original. You could do the exclusion like that, or you can do the exclusion like the request that I did earlier. This will then give you all of the logs with that particular message. So access denied 403 phase 2, pattern is empty, an empty regex for args user token. Awesome. So that's able to correctly identify the reason why that traffic is being blocked. Then there's another ModSecurity rule that will block normal brute forces against the main login page. So there's also a nuclei template for this. However, there is a bug within the ModSecurity. It's kind of if the browser doesn't follow redirects and you're able to get the successful codes from the response headers, being your go to index.php or login.php, it will actually work. This is just a bit of a strange one, so just to be aware of, but there is a rule for it. It just doesn't work as you'd expect. This rule will block FuzzFoster full requests, but it won't block nuclei requests. Just something to keep in mind. But that is all for the reconnaissance of the damn vulnerable web application on medium security. I hope you've enjoyed, and I will see you in the next one.